This is Chapter 13, Section 3, and it's on climate change. The objectives are to explain why Earth's atmosphere is like the glass in a greenhouse, to explain why carbon dioxide in the atmosphere appears to be increasing, to identify one possible explanation for the increase in average global temperature, and to describe what a warmer Earth might be like. So rather than reading the text in this slide, I'm going to jump to this picture to explain the greenhouse effect. So you have the sun here, and the sun's providing us with light and energy, and it comes through here, and much of this energy is going to get absorbed by the Earth. However, some of this energy in the form of infrared light, and to remind you what I mean by infrared light, this is the electromagnetic spectrum. Let's go ahead and write that, electromagnetic spectrum, where to the left of this slide, this way, you have a shorter wavelength, higher frequency, and higher energy. So this is going to be the area of the energy provided by the sun. It's going to be of higher energy, and then further to the right, it's going to be the area of lower energy. So the sunlight's coming in, and much of this higher energy is going to be absorbed by the Earth, and then it's going to be reflected back into space in the lower energy infrared region. And that infrared radiation is going to, some of it's going to escape out into space, and then some of it's going to get re-radiated by the greenhouse gases. That's what this kind of hazy little region is here. It's the Earth's atmosphere that has these greenhouse gases where they're going to absorb some of that heat, some of that infrared radiation from the sun, and pass it back down to the Earth. So in effect, these greenhouse gases, you can almost think of them as little tiny blankets that are going to be heating up the Earth. So each time we add more and more greenhouse gas to the Earth, it's almost as if we're slowly adding layers of blankets to the Earth, where eventually it's just going to keep heating it up. Now, not every gas in the atmosphere is going to re-radiate that infrared radiation. The ones that do, though, are going to be what are greenhouse gases. So some examples are water vapor, carbon dioxide from our fossil fuels, methane, and nitrous oxide from our fossil fuels. And methane, this is going to come from a lot of your decomposition of organisms. Cow farts produce it. And the ones that are contribute the most to the greenhouse gases are going to be the water vapor and carbon dioxide in the atmosphere. Water vapor we can't do a whole lot about because we need water, and that's just part of the water cycle. But carbon dioxide we can do something about because that's coming from our fossil fuels that we're burning. So, what kind of led to this whole discussion about global warming and carbon dioxide and greenhouse gases, kind of can be traced back to a geochemist named Charles Keeling. And Charles Keeling installed an instrument at the top of this tall tower in Hawaii, over at the Mauna Loa Observatory. I know I'm not pronouncing that right, but anyway, Keeling wanted to precisely measure the amount of carbon dioxide here. And the reason why he chose this observatory is because it's located thousands of miles off the Pacific Ocean. And so the reasoning is, as that air is traveling across the Pacific Ocean to the observatory, it's going to be mixing and swirling, and by the time it gets over to this observatory, it's going to be the carbon dioxide levels are going to be something of an average for the entire Earth. Meaning that he can, get a measure for the carbon dioxide content for the Earth as a whole. And what he found was that the amounts of carbon dioxide levels were slowly rising as he would keep taking these different measurements throughout different years. So a lot of the carbon dioxide that's going to be released is going to dissolve in the oceans, or it's going to be used by plants for photosynthesis. However, that excess carbon dioxide is just going to go into the atmosphere and form and make up your greenhouse gases. Carbon dioxide levels are going to peak during the winter, because during the winter you have grasses that die and leaves that decay, and they're going to release a lot of the carbon that was stored within them. And also, what happens, during the winter, it's cold, you have less sunlight, you don't have as much photosynthesis going on. And remember, photosynthesis is how plants make their food, where they take that carbon dioxide from the atmosphere and combine it with water and sunlight to make their food. What that means is during the summer, you're going to have the lowest amount of carbon dioxide because you're going to have more plants growing, and they're growing because they're using that carbon dioxide for photosynthesis. So, as these measurements of carbon dioxide are being taken, you're going to see these fluctuations from summer and winter, but it's becoming obvious that, during winter, the amount of carbon dioxide was becoming even higher, and then that level wasn't dropping down as low during the summer, and slowly you're kind of getting it inching up step by step to where it was increasing. And since 1958, the level of carbon dioxide has increased by over 20%. And the biggest cause of this is going to be because of the burning of fossil fuels, by industry and from the driving of cars. And this is rising carbon dioxide levels throughout the years, where these peaks here, this peak right here is the winter high, and then your summer low, where you can see that it fluctuates, but then we have a best fit average line, and you can see just how much it's risen each and every year. It's rising, fairly linearly. So the thinking again behind global warming and how greenhouse gases heat up the Earth is going to be this re-radiation, or the releasing of the infrared radiation back onto the Earth's surface, rather than allowing that infrared radiation to escape back into space. And when you compare carbon dioxide in the atmosphere and average global temperatures from the past 400,000 years, that's going to support this view that carbon dioxide does this and other greenhouse gases. Okay, talked about that, and this is just a summary slide on where these greenhouse gases are coming from. Global warming, it can be defined as a gradual increase in the average global temperature, caused primarily by the increase in these greenhouse gases. And the next thing we'll be talking about is different computer models that we can use to predict global surface temperature and predict what the climate's going to look like in the coming years. And this is a graph showing how the temperature has varied and increased throughout the years. So you can see that you have some decent amount of variation from each year, and this line right here is the average line, the average difference from the average from the 20th century average. So if you're below this line, then that means it was a cooler year, and then if you're above this line, like we have for most of these years here, that's going to indicate that the Earth is warmer during these years. And the tricky thing with global climate change is that the temperatures aren't going to be rising at a constant rate. Some years it's going to rise more, and other years it may even fall a little bit. But the consistent trend is that over time it's going to keep rising. And how this change in carbon dioxide level happens, and the causes of it, it's going to create some different weather patterns where you could have some flooding and extreme temperatures, extreme flooding in one area of the Earth, and then extreme drought in another area of the Earth. Meaning that the effect of climate change isn't going to be the same in one specific area. In other words, not every area is going to be, having, drought. Some it's going to be kind of more extreme. More kind of poles of the weather, where you're going to have extreme flooding or extreme drought. Not as much middle ground with the weather. Because of this, scientists prefer global climate as opposed to global warming, because global warming tends to just imply that all that we care about is the warming of the Earth, or that all areas of the Earth are warming, whereas global climate change kind of gets a little bit more at the issue here. That the climate will change because you're warming the Earth. So some of the modeling for climate change. So the basics of it is you start with these things called drivers, and these drivers are going to be things like solar input, so the amount of sunlight we're receiving, wind patterns, cloud cover, and so you take these drivers and you see how they how as you vary the amounts of these, how they're going to affect the response variables like troposphere temperature, sea surface temperature, ice cover, and sea level, um, and then you kind of combine these into these equations that can be then put into these complex models. And how we test these models is we'll look at historical conditions, previous, okay, we know the temperature was, at this, amount back in, 1985, and you try to kind of test your models to see, if you put in these variables, will we get, will they properly predict what we know to be true? And, there's tons of different models, and each time we keep putting in these different data for these different models, they're all predicting a fairly similar thing, namely being an increase in the global temperature, global warming, leading to climate change. And so I think some of the consequences of a warmer Earth, birds are nesting a couple weeks earlier than they did 50 years ago in North America. In Britain, plants are flowering earlier, up to 55 days earlier. Um, you're going to have rising sea levels. And again, it's going to vary depending on where you're at on the Earth. And the reason why sea levels are going to rise is for two main reasons. The first is that as water warms, it's going to expand. The molecules that make up water, as they're getting more energy, they're going to be bouncing around more, which means they're going to take up more space. And in addition, the ice that's currently covering land, as it melts, that's going to turn into the liquid water that's going to flow into the oceans. So as you have rise in sea levels, it's going to flood certain coastal wetlands and other low-lying areas. You can have some eroding of beaches. And in some of your bays and estuaries, they're going to have an increase in their salinity, or the amount of the salt. In coastal freshwater aquifers, might increase in salinity as well. And basically, essentially it's going to negatively affect aquatic life, and it's going to decrease your freshwater resources because you're adding salt into these freshwater resources. The warming of ocean, a lot of the warming is going to happen in the oceans, and so the absorption of these of the energy from the oceans is going to, in the form of heat, is going to kind of feed these hurricanes and typhoons and make them more intense, and make them happen more often. And as I mentioned earlier, you'll have severe flooding in some areas, and then severe droughts and fires in some other regions. And some human health problems that are going to come from it are a greater number of heat-related deaths. Because plants will be flowering earlier, that's going to increase the amount of pollen, which is a major allergen for people. So people will be suffering from allergies more often. Warmer temperatures can help feed mosquitoes and make them grow more, to where mosquitoes are vectors or carriers of diseases like malaria and dengue fever. So these mosquitoes can start to establish themselves in areas that were previously too cold for them. And then in agriculture, drought is not good for growing plants, and also higher temperatures isn't good for crop yields, and so that's going to lead to more irrigation to try to bring water to these drought-ridden areas, and that's going to further deplete aquifers that are already being overused. The changing in climate, so the drought arising in certain areas of the earth is going to change the range, or kind of how far certain plant species are spread out. It's going to change the composition of plant communities. So you might have um, certain plants joining communities that they weren't previously a part of. Um, Trees might begin to start to colonize, start to move northward into cooler areas because where they're at currently is too warm. Um, and you'll have a loss in diversity. And basically, it's just going to kind of completely mess up different ecosystems. Um, and then you throw fires into the mix. Fires will burn up different ecosystems and make them have to kind of start over from scratch. Um, Birds, their migration patterns, they may not migrate as far south during the winter because it's warming up. The warming of the surface waters of the ocean could kill off certain zooplankton, and these zooplankton, which are these tiny shrimp-like animals, they're food for other marine animals, which will decrease the amount of fish supplies that are in our waters. Warming tropical waters can kill algae, which algae feed the corals, which make up our coral reefs. So you'll start to lose your coral reefs. More carbon dioxide dissolving into your oceans. That's gonna decrease or increase the acidity of the water, decrease the pH. So that's gonna disrupt um, marine food webs. Basically, none of this. There's no really benefit that's coming out of global climate change. The International Panel on Climate Change issued its fourth assessment report in 2007, um, providing some future estimates, and it reported that the average global surface temperature had increased by 0.74 degrees Celsius since their third report in 2001. Um, and this temperature increase is global, and it's especially going to be higher in northern latitudes. And in addition, they reported higher sea level rise and and an increase in the amount of atmospheric greenhouse gases, primarily from human activities. So because of global climate change, it's kind of um, caused nations to come together and try to figure out different ways that we can prevent global warming from happening. Certain projects that have been initiated have been reforestation projects. Because plants will take in carbon dioxide to make their food. If we can have, more, we can keep, planting trees and stuff. We can kind of suck out some of that carbon dioxide from the atmosphere. Um, However, it gets into some complicated issues when you get into the some of the economics and the politics of climate change because using coal, um, uh, driving our cars, these are all things that help economies function, and so countries, you know, coal is a cheap energy source. Fossil fuels, we like our fossil fuels, and so it's kind of controversial and people don't really like to talk about climate change, especially those who are involved in those industries because it's certainly isn't as profitable for them. And then you get into areas with developing countries where as they're developing, they're relying on coal and they're starting to drive more of their cars, and so um, for some of those developing countries, they don't necessarily feel like it's fair that they are that they didn't get to have the chance to benefit from um, getting to produce all the CO2 that the developed countries got to produce. So they kind of feel as though, they shouldn't be the ones having to pay the penalty for the damaging of the earth whenever it was more of the developed countries that were producing a lot of these greenhouse gases. Um, Regardless, by 2035, it's projected that developing countries are going to make up about half of all CO2 emissions. Because these developing countries will begin to have people who can afford cars and have more power plants. The Kyoto Protocol is an international treaty first negotiated in 1990, and it was just countries that came together trying to find ways to reduce greenhouse gas emissions. And the biggest thing to take out of this graph is the change from 1995 to 2035, where 1995 you only had 27% of CO2 emissions coming from developing countries. compared to 2035, where it's projected that that half of all CO2 emissions are going to come from developing countries. Okay, that's going to do it for this lecture.